Okay, this lesson right here, we're going to talk about rectangles and squares. What you got to keep in mind now, guys, is that rectangles and squares are still parallelograms. So the 5 principles that went with parallelograms still apply to rectangles and squares. And what were they? We know that opposite sides are parallel. We know that opposite sides are congruent. We know that opposite angles are congruent. We know that the diagonals bisect each other. And we also know that consecutive angles, or angles right next to each other, are supplementary. They add to 180. What else is going to take place? All right, man, as we're going from shape to shape right here, what we're doing is we're getting very, very specific in some of the ideas. First and foremost, the easiest thing, again, all 5 of those principles are going to take place with a rectangle. Now, the thing that's a little bit different now and very specific to rectangles is this. These opposite angles are congruent, but guess what? All of them are what? You're right. All 4 of these guys are 90 degrees. Okay, so that's very, very specific information. The other thing that we know about a rectangle is that the diagonals, okay, we know that they bisect each other. That is exactly true, just like any parallelogram. Those 2 guys, they will bisect each other. Here's one thing that you got to keep in mind. These do not make a 90-degree angle. There is no right angle right here with a rectangle, okay? Here's what we do know, though. The diagonals bisect each other, but check out my marks of congruency right here. See how this length right here from there to there is the same as it is from there to there. Now watch this. How many marks of congruency did I put here? Also only put 1, which means what? All of these, half of the diagonals right here, are the same length. What else do you think that implies? That the length of this diagonal right here is exactly the same as the length of that diagonal right there. Okay? So again, what makes it specific? What makes a rectangle specific? All angles are 90 degrees, and the diagonals are congruent. Okay, so those are your 2 big ideas. Those are the 2 things that we add above and beyond to still all the same things, or all the 5 principles that go along with all parallelograms. All right, so let's have a look at some things. And how can we apply this information? Okay, our quadrilateral right here, RECT, is a rectangle. So as soon as we know that, I know a couple of things. I know all 4 angles are 90 degrees. I know that for a fact. I know this diagonal bisects this diagonal. And I also know that these 2 diagonals are the same length. Okay? And then again, the same 5 properties that go with parallelograms. What information do we have? What are we actually going to write down on the drawing here? The distance from R to A, and it would help a great deal if you knew where A was. Here's A. A is going to be my point of intersection right there in the middle where the 2 diagonals actually intersect. Now what I know, RA is x plus 9. Fill it in, man. There's RA. I know this guy is x plus 9. What else do we know? RC is 3x plus 15. Now this was a little bit more difficult to write, right? So the whole thing, man, the distance from there to there is going to be 3x plus 15. What we need to do, number 1, is we need to find x. So let's just find x first. What do we know about the relationship between x plus 9 and 3x plus 15? More like this. What do we know about the relationship of RA as it pertains to RC? What you should know is that RA is half of it. So how could I express that? If I took RA and I doubled it like that right there, 2 times RA, then it would equal RC. So now what we have to do is substitute in the information that we know. So 2 times RA, which is x plus 9, is now equal to RC, which is 3x plus 15. Now keep in mind, what do we got to do? I've got a 2 outside the parentheses right here. I've got to distribute it to everything. So 2x plus 18 is now equal to 3x plus 15. Where the variables, opposite sides, get them together. So minus 2x So we have 18 is equal to x plus 15. Get the x alone. So x is equal to 3. All right, so I've done a good job finding that information right there. So with that now I need to plug that guy back into some expressions that we have to find the distances. What is RA? Well, here's RA. What is my expression for RA? The expression for RA is x plus 9. Well, x is actually 3. So 3 plus 9 is 12. So that means that the distance from R to A is 12. Now we're asked to find the distance from E to A. So what we really want to find now is I want to find out what is this distance right here. Man, let's recall that one thing that we talked about, what a special property of a rectangle is that the diagonals are congruent. So because the diagonals are exactly the same length, if R to A is 12, like we found here, what do you think E to A is? It's 12 as well.